Hello everyone. In this video we're going to talk about the differences between ExactFlat's pre-flatteners and the ExactFlat optimizer. To begin, we'll flatten this mesh and then we can start having a look at the differences. So the ExactFlat pre-flatteners are the first stage of ExactFlat flattening. Flattening objects in ExactFlat is a two-stage process, the first stage being the pre-flatteners and the second stage being the optimizer. Both of them produce flat patterns, however the way in which they produce flat patterns are very different, and in fact you need to use both pre-flatteners and the optimizer to produce a production quality flat pattern. The pre-flatteners, the biggest characteristics of the pre-flatteners are they are extremely fast. So for instance, I can use the fracture pre-flattener to very quickly produce a flat pattern. However, another key characteristic is the flat patterns they produce are not production ready, that being they still have strain in them. In the case of this helmet, even though the 3D model is symmetrical, the patterns produced by the fracture algorithm are not symmetrical. By contrast, the optimizer is not fast at all, but it considers the whole model in relation to pattern in relation to the model, and it's going to reduce the average energy density of the pattern to produce a production ready final flat pattern. It also does this using the mechanical properties of the selected material, whereas the pre-flatteners do not use material properties. So in ExactFlat, the correct workflow is to first use a pre-flattener, and the reason we do this is to produce a flat pattern that better resembles the final shape, as well as eliminates any kind of folds or wrinkles that may be in the pattern. So once you have a decent starting position with no folds or wrinkles, you then use the optimizer to optimize the pattern and to reduce the energy density across the surface of the pattern, and the optimizer will restore any kind of symmetrical shape that the model may have had, and it's going to produce a production ready model. So I used the fracture algorithm on these, and with this fracture algorithm, depending where you select the model, you get a different pattern. And as I fracture, we're getting different shape, and we can see that we still have a bit of a fold or wrinkle here. It's easier to see them if we turn off the tessellation, then turn off the highlights. We can very easily now see that we've got quite a few folds or wrinkles. So there are a number of strategies to do this. For this video, I'm just going to use a different pre-flattener. I will use Pelt, and when I select the mesh, in this case Pelt is not fixing it, so I will try the automated flip triangle removal, and it has removed all the folds or wrinkles. So in the case of this pattern, we can use the pre-flatteners at any point we want, as many times as we want, and we're always, depending on the tool we use, in the case of fracture, we're always going to get a different shape depending where we select. But as long as optimize is always the very last operation we do, we will end up with a production ready pattern. So I will turn back on our strain analysis and triangulation. So we've used the pre-flatteners on here, we've produced patterns. In the case of this one down here, it looks fairly symmetrical, which the input is symmetrical. In the case of this one, we've simply eliminated a lot of strain on the pattern already. So we will use the optimizer to finish the flattening process. We're going to accept the defaults and use a simple cotton, and when I click OK, the optimizer will start running. And very quickly we're going to take these pre-flattened shapes and we're going to very quickly see a more symmetrical shape appearing as the optimizer works to minimize strain and sag on the pattern. So the symmetrical nature of the shape may not be fully restored, and that has to do simply with the triangulation of the mesh. So for this piece here, we can see that we've got local zoning of the triangles up here, which may indicate some kind of defect with the original 3D model. This may inhibit the ability of the optimizer to fully resolve the shape here. We may also have problems with the optimizer because of the shape and the cuts that have been created. If we're trying to optimize extremely complex curved objects with extreme complex curvature, double curvature, very, very wavy, the optimizer may not be able to fully resolve it. In that case, you may want to look at splitting up your mesh to try to allow the shape to be optimized better. But the key points to take away from this video are that the pre-flatteners are the first stage flattener. They are always the first ones you are going to use, and they are designed to very quickly give you a flat pattern that is not optimized. The pre-flatteners do not use material properties or mechanical properties of the material at all. They are designed solely to very quickly get you a flat pattern, and they are tools used to minimize strain and sag going into the optimizer and to eliminate folds and wrinkles in the pattern. By contrast, the optimizer is the second stage of the flattening, so the optimizer is always going to be the very last thing we do before exporting a DXF, and it is designed to minimize strain and sag across the entire surface of the pattern and to produce your production quality pattern. So the optimizer does use mechanical properties in the material, and it also restores the symmetrical shape of the pattern. So I'll go ahead, I'll skip this piece here, and we'll start optimizing this one down here, and we're going to notice that the pattern is going to start we're going to notice the color change, which indicates strain is changing from green down to cyan, and the symmetrical shape to the pattern is emerging much better. Thank you for watching.